Today we are covering multi-head attention. Learning multiple relationships at the same time. The goal is not to memorize a slogan. The goal is to build an interview-ready explanation that moves from intuition, to mechanics, to trade-offs, and then to a concrete example. Intuition. One attention head can focus on one pattern. Multi-head attention gives the model several smaller attention spaces so different heads can track syntax, references, positions, or topic cues in parallel. If you remember only one thing, remember the shape of the problem. Raw information is transformed into a representation that makes the next decision easier. Core mechanics. Project inputs into multiple sets of Q, K, and V. Each head performs attention independently. Head outputs are concatenated and projected back. Different heads can specialize in different relationships. Total dimension is usually split across heads for efficiency. The compact mental model is multi-head X equals concat head H W. Do not rush past the symbols. In an interview, define each part in plain language before you talk about implementation. That makes you sound like you understand the system, not like you only memorize notation. Common traps. More heads are not automatically better. If dimension per head becomes too small, head specialization is useful but not guaranteed to be human interpretable. Multi-head attention still has quadratic sequence cost. Implementation must keep tensor shapes clear. Concrete example. In a sentence, one head might connect a pronoun to its noun, another might track punctuation or clause boundaries, and another might follow the main topic. Walk through the example slowly. Say what changes at each step, what stays fixed, and why the operation helps the model produce a better representation. Interview checklist. Explain why one head may be limiting. Describe split attend concat project. Mention specialization examples. Discuss headcount trade-off. Be careful with dimensions. A strong final answer for multi-head attention should have 4 beats. First, give the intuition. Second, name the components. Third, describe the formula or data flow. Fourth, mention the trade-off. If you can add one example, you will usually sound much more practical than someone who only gives a textbook definition. Now let us rehearse the answer in a more conversational way. Start broad. What problem are we solving, and why did this idea become useful in modern AI systems? Then narrow down, what data structure or tensor is being manipulated? Then explain the operation. What is multiplied, normalized, added, masked, or learned? Finally, connect it to behavior. Faster training, better context, more stable gradients, lower memory cost, or clearer generalization. For interview practice, avoid 3 mistakes. Do not give only math without intuition. Do not give only intuition without naming the mechanism. And do not pretend there is no trade-off. Most AI interview questions are really trade-off questions wearing a concept label. The best answer shows you know when the method works, when it becomes expensive, and how engineers usually manage that cost. Quick recap: multi-head attention. Learning multiple relationships at the same time. Use the mental model, define the pieces, give the example, and close with the practical trade-off. That is the answer structure to keep in your head. One more interview rehearsal. Explain it as if teaching a teammate. Define the input, describe the transformation, name the output, and close with why the design choice matters in real systems. This habit turns a memorized answer into a practical engineering answer. Second rehearsal. If the interviewer asks for more depth, connect the idea to tensors and runtime behavior. What is stored in memory? Which dimension grows with sequence length, hidden size, or number of heads? Which part is learned, and which part is a fixed rule? These details separate a surface-level answer from an engineering answer.